Whether a sensor package is placed on an airplane, a spacecraft, or down the borehole of a wellhead, the cost of failure can often be measured in hundreds of lives or millions of dollars. For these harsh environment situations, engineers have to pay particular attention to design choices, with the two most important factors for the PCBs being their operating temperature and thermal cycling. When the temperature of a PCB increases, the interatomic distances of the materials used increases, causing them to expand. The laminate that most PCBs are built on use a specific weave to reduce in-plane expansion in the X and Y axes, but not in the out-of-plane or Z axis. When selecting a laminate material, check the properties that minimize both in-plane and out-of-plane thermal expansion. Due to the different expansion rate between copper and most PCB base materials, when the board is heated, the Z-axis board expansion leads to a shear stress on vias. To reduce the risk of solder thieving, do not leave open vias beneath or near solder pads. For vias near pads, tent the vias, using a solder resist layer to provide a barrier between the solder pad and the via. And for vias beneath pads, the most reliable option is to use epoxy-filled and capped vias. Transient liquid phase sintering paste, TLPSP, is a type of solder paste that liquefies once. After first melting, TLPSP's melting temperature increases significantly. This makes the paste useful for harsh environments, where there is a concern for solder melting again in the field. Focusing on thermal management will help improve your board's lifespan and reliability, but it is just one part of the equation. Be sure to look at other factors, such as incorporating heavy copper into PCB designs. Contact Advanced Assembly to learn more about designing for PCB assembly at aapcb.com.